Hey YouTube, it's Petey Two Finger. In this video, I'm going to give you the nitty-gritty on converting an Arctic Air swamp cooler into a magnetic stir plate. So this is the unit that I used, the Arctic Air Ultra. It's got the trapezoid-shaped speed button. These are the 3 LED indicators, so when you turn it on, nothing happens when you plug this in until you hit this button once. Then all 3 LEDs come on. The fan will spin up. It will hit a speed plateau. 3 seconds later, it will go even faster. At that point, you hit this button again. This LED shuts off, so we're on fan speed 2, and it reduces. Hit it again, we're on fan speed 1, and it reduces even more. This button changes the, there's external LEDs besides these 3 that change colors. And that's stupid, we're not gonna mess with that. It is a 5 volt 2 amp adapter. I tried a multi-speed, multi-variable voltage, like 3, 4.5, 6, 7, 9, 12 adapter. And those tend to max out around 300 milliamp maximum current output. This calls for 2 amps. So 300 milliamps is a third of 1 amp. It's a lot less. And this thing, when I ran it at 6 volts with 300 milliamps, it came on, but the LEDs started blinking. They were dim and they started flashing. And then the fan was like, are you serious? Like it was kind of spinning, and then it just shut itself off. So I jacked the voltage up, turned it up higher. The LEDs went unbelievably bright, and I burnt out the color changey section, which isn't a big deal because you can't see it anyway. It isn't powerful enough with the way these are designed, with the way we modify them, to shine through and change the color of your liquid unless you mount them really creatively. So I would say don't mess with that unless you're a pro modder. Now, why would I ever think to take an Arctic Air and convert it into a mag stir plate? 2 reasons. 3 actually. 1, they're in season. You can find these things at resale. Number 2, and they're cheap. It comes with a fan that you need. It's the exact part that you need to build it. The main part, it has it in there. And number 3, it has this PCB which has a speed controller, which is super cool. And it's an easy tear down and it's an easy mod. Now you can see here, this is the older model Arctic Air. It has the milky white plastic front. They've changed them. This is the Arctic Air Ultra. This is old. It's got the milky, and you can see the trapezoid shaped speed button. So this is what you're looking for if you're gonna follow this tutorial to a T. The other models, you can use the newer one. And you can see here the Arctic Air Pure Chill, as they call it. Has a clear panel and there's 4 buttons. There's additional features that we don't need. This is the one that's newer. If you run into that, you certainly can use it. This tutorial was made around the older unit that just has these 2 buttons, trapezoid shaped fan control, and the 3 indicator LED. If you got an aftermarket unit, like look at this Chilly Willy unit, it's got the 3 speeds. There they are, the 3 LEDs. The stupid 8-color light that we're going to ignore because we're not 5 years old anymore. So this would be fine. You could even take this board, pull it out of there without soldering or anything, just cutting the wires and twisting them together. Screw this board with the little mounting holes onto your box, and there you go. You wouldn't have to modify anything. You could just push the button. You know, so you can get as crazy as you want with this, is the point. Now the newer unit, the Pure Chill, has the soothing night light because anybody that bought this would have the intellect of a 5-year-old, and they would immediately be changing the colors of these lights. The cooling control operates some sort of a mister. Can you run this PCB in full functionality without the mister plugged in? I don't know. I never had one of these. That's why I'm saying this tutorial isn't written for this, but I'm sure you could get past it. I'm sure it would work. So the turbo boost means it's another momentary contact switch that I would have to purchase, doubling the price of the project. 4 fan speed settings, and the 4 setting is off. So I said nitty gritty, let's get to the nitty gritty. Here is our helpful image. When you open the thing up, in front of the fan is this spreader. So this is a V-shaped piece of plastic, and there's a sensor on the top of where the reservoir is. So there's a couple screws holding this in. There are screws on the side for the panel. I use gloves and just tore mine apart. This sensor, let me turn my crayon on. This sensor has a plug. Wow, look at that plug, huh? this white, there's two white plastic jacks on this PCB, okay? One is for the sensor. And this you just rip out of there. What you could do is cut these. If you didn't want to solder this, you'd cut these here, twist the wires together so it's providing a hard short. Because it will not run properly. This project wants to see, like basically how I did it. I turned this board over. Now there's only two white jacks. One is where the motor connects. Please forgive that this wire isn't red. The other is the sensor, okay? So you can't really get them confused. You turn this over and solder hard short the pins for the sensor to enable proper operation. Now mine, you know, I mentioned it runs off of a goofy power supply. These power supplies are what they use for USB hub. 5 volt, 2 amp, 5 volt, high amperage, 5 volt. So that's where you get this. Now for me, my jack, the jack is mounted on the PCB here. It was broken off, okay? And you can use your meter on a continuity test, cut the cable, you know, put it here, see, okay, this is center hot. This wire is the wire that goes to the center. Plug it in and then put the music on one probe here and one probe here to determine which one is plus and which one is ground. Because don't go off what I'm telling you, I might be wrong. What I remember with mine was this was gone. This pad was gone. There was a little strip where I might have been able to tack onto some solder, but probably not. And this appeared to be the ground. Now, there was a capacitor, an electrolytic power filtering capacitor with the positive lead here and a minus lead here. And I assumed correctly by testing it with my meter that this was connected directly to where the power input was. So I tacked my power wire. I have a ground going to a power jack. 5 mil outer diameter, 2.1 mil inner diameter power connector. And I ran my positive wire over here. Because this was broken off. I could not solder to this. So, and it worked just fine. That's the powering. And you know, make sure you short this baby. Now the motor connecting one, you can cut this wire in the middle and then extend the wires because you'll probably need to. But one thing I would recommend is running a voltage regulator board. This is a LM2596. Yes, you can use a LM317, but that gets hot. It requires a heat sink and I don't recommend it. You can buy this LM2596 and these cost like, wow, look at that 5. Let's see if we can, yeah. LM2596, they're like $1.50 to $3 on eBay or Alibaba Express is where I get them. So you hook up a potentiometer. Like actually, if you measure, if you take a look at this onboard potentiometer, and you adjust this with a screwdriver. There's a little tiny brass fitting. You could mount this thing where you could put a screwdriver in, you know, have a hole above it, and you could tweak that manually if you didn't want to do a lot of soldering, or you can remove this, solder in 3 wires to a 10K pot, because this part, the onboard adjuster, is a 10K. And then you'll have a volume control. And what this enables you to do is, yeah, you have your fan speed controller where you get your 3 speeds, but with this board, with this pot, this control, okay, this lets me, I can turn it on, I can hit it twice to get to the slowest fan speed, then turn this down, turn it down, and get this fan to almost stop, which is really what the functionality that I demand out of my mag stir plate. So we'll talk more about that later. I know this is seeming overwhelming, like, oh, you're adding this circuit, you have to remove this and remove that. This is basic hacking, okay, guys? So in order to duplicate this button, I mean, there's a couple of holes on the board. You could just screw 2 screws in to the outside of your box and mount this outside and just press these buttons, and it would do the same thing as what I did. I wanted to hide this board inside of it and just have, you know, my box, excuse me, my chassis with a nice little button here and then a knob. So I can press this button and then turn the knob. And that's the design that I came up with. And in order to duplicate this button, what you do is you put a little flux on these. These are switches, okay? You press this in, and it's a push button momentary contact switch that are soldered onto the PCB. So if you use your tester, you find out that these are the points to connect to. These two or these two. And then if you want to play with the LED color, we're not going to play with that. So you solder a wire onto here, you solder another wire onto here, and then you have your push button switch here, which is upside down, and you press that and it shorts this out and changes your fan speed. So typically I will take my soldering iron, I will put some flux on here first, grab some solder on here and tin it, and then take the wire, hook up the switch. The same way, you know, these switches have little terminals. I like to put flux on there, and then I tin it first, put a little solder on it, take my wire, strip it, put the flux on it, tin it first, and then everything solders together really nicely, and you don't even really need extra solder if you tin everything in advance. So that's how you duplicate this control here. Again, this sensor needs to be shorted, okay? You need to get power going. Okay, you need to wire in your power jack, and you need to either extend these wires or go if it reaches on your project, that's fine. Don't extend them, and then you can always cut in that other circuit with the pot, the external pot, to act as another adjuster. So if you flip this board over, there's 3 LEDs, and they're labeled 2, 3, and 4. Now, the polarity of this, the ground side of these LEDs is over here. The positive side of these LEDs where they hook up is on this side. So positive connection, positive connection, positive connection, negative, negative, negative. Now, however you do this, you can mount this so it's visible, or you could drill holes out and then fill those holes with clear hot glue and have this line up so you could see it. Or you can unsolder these. I unsoldered them. So I put my soldering iron on here with some solder on the tip, and it just heats these up and they come right off. They're so tiny, leaving these 2 tiny microscopic pads. So I will go back over that, clean it up with a Q-tip and some rubbing alcohol, then apply flux to it generously, come back with the iron and some real fine diameter silver solder, and put extra beads of solder on these points. Then I run real skinny wire in here, single strand, solid core wire, comes in, oops, I got that backwards. And what I'll do is I'll put a piece of like masking tape on it to hold it, and have this stripped and tinned, and have this with the blob of solder on it, and then you heat that up, make sure the wire sticks to it, and yank on it. You're going to tug on this wire and make sure that this is a good connection before you move on. And you need to have a positive wire on each one of these after you remove them, and then a negative wire on the other side. And these will hook up directly to your LED. You do not need a current limiting resistor, because on the PCB, if you look, right next to each LED is the appropriate current limiting resistor. So if you want to play, if you're really good at SMT soldering, you can remove these and put lower values in to get brighter LEDs or dimmer or whatever you want to do. I just ran 5mm LEDs, and they're bright enough. So how it looks when you're finished is I have these wires running down across the PCB because of my design, and I put a blob of hot glue here, and then I put a blob of hot glue over specifically right in here to hold this down. It's kind of messy. It's a big blob. just to hold it down, because these are micro soldered points. They're not through any hole or anything. They're just tacked onto the board. And if anything is going to break, it's going to be those. And I didn't want my LEDs dimming or failing. So I put a big blob holding the wire and then a blob over each LED spot. I used my mounting holes and it came together fairly nicely. When you're working with these stir bars, you want to get one that's the matching diameter of your fan. So like, let's say your fan is, the inner diameter is that. Well, you need to measure the diameter and then get the same size or just under it stir bar. Now, this type of stir bar here, it has this little rim. I found this to be annoying. It made noise. Obviously, I didn't consider it, but I think the longer the stir bar, also the bigger in diameter that way, and the more powerful the magnet is. So the bigger the better, in my opinion, because the faster the RPM of this thing spinning, the more chance it goes whipping off and loses its magnetism from centrifugal force, and then ding, 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 ricochets all the inside of your vessel. So lower speeds are better, and a bigger, stronger magnet is better when it comes to doing this. This shape, the oval shape, is what I recommend. They run quieter. And I mean, every vessel is different. If the bottom of your vessel is shaped, if it's a goofy shaped inner vessel where it's like shaped like this or something, you know, I don't know. If it's shaped like this, it's gonna give you more distance this way away from your magnet, and you're gonna lose some force. So ideally, you know, excuse how messy this is, a flat bottomed vessel is gonna work really well, or a minimal humpage, you know. If that would be better than a big hump, right? And I found that this oval shape is quieter, and if you're running caustic or whatever you're running in your chemistry experiments, PTFE is always good. So just look for a PTFE. They should be, at this point, they should be selling PTFE mag stir bars. So that's the tutorial. If you have any questions, you can get a hold of me via email. I don't counsel people on hacking or builds through the YouTube comment section. That's incredibly rude to ask me to do that in a tiny little rectangle and in public. You need to email me. So you can find my email address. It's here. It's my username at yahoo.com. You can email me and leave a comment so I know who you are. Let me know, and I'll help you out. But I don't like doing that in the comment section. It's a lot to ask. You should be able to figure this out. It's a fun, easy project. It made sense to me. I'm sure there's other easier ways of doing it. It presented itself, and I went through with it, and I thought, I bet you somebody else would find this useful, because I had built one. I had bought a PWM circuit, and it didn't really work very well. I had to alter the value of the potentiometer down from 100K to 1K, and even with my variable speed, variable voltage power supply, it's not really ideal. It could be a lot better. The one that I made, the latest one that I made out of the Arctic Air, it smokes the old one. So that being said, I hope you enjoyed the project. I know the video was long. What can I say? It's a lot of information. And I'm not here to hurry up and for anybody. You know what I'm saying? I reshot this video a few times to try to get it down under a half hour. And I don't appreciate people bugging me out about time. You know, if you don't have patience, you need to find another hobby. And I shouldn't have to rush through the stuff at breakneck speed either. It's just not my style. So, no apologies. Best of luck with your hack. Get a hold of me if you get stuck or you have some questions. I'll be more than willing to help you out. Try to keep yourselves cool, or if it's cold, try to stay warm. Hug your pets, and peace.